All right. So, welcome everybody. My name is Kreuzer. I'm from Deutsche Telekom, from Germany, and my Dutch is very, very bad, so apologies for having the talk in English. I'm actually a real smart home guy, I would say. I'm involved in smart homes since many years, and I'm active in many fields. So at Deutsche Telekom, I'm working in the KiwiCon development, which is a smart home platform, a commercial one that we developed there. At the same time, I'm the project lead of an Eclipse Foundation project, the Eclipse SmartHome project, and I'm also the founder of the open source project openHAB, Open Home Automation Bus, which the one or other might know. So before I start, just out of interest, who of you is already living in a smart home? Okay, a few. Who plans to get started with that? All right. Almost all the rest. Wonderful. So usually, when you want to get started, you ask yourself, okay, what kind of device or use case might be a nice one, and very often you find something like a smart plug, like this Belkin Vimo one here, which you can hook up to your Wi-Fi. You get a smartphone app for that. And here, you can play around with that. Can remotely from all over the world now switch on and off your toaster or whatever you plug in there. So you say, well, you like it, quite fun, so let's buy some more stuff. I said buy some more stuff? Yeah, buying some more stuff, having more devices at home, having some more apps, more fun. You go on, and you go on, and you end up with a whole lot of devices and a whole lot of applications. So I think you're starting to see the problem here already. So although you have many smart gadgets now, you didn't really end up with a smart home because you just bought many isolated solutions. So you have the one application for the one thing, another application for another one, but they simply don't talk to each other and they are not interacting. And the smart part should be about really automating things for you, thinking for you, and this is simply not possible that way. Now, if you have a closer look, what do all these devices do? Well, in order to have their own application, they also hook up to their own cloud service so that they can be remotely controlled. And, well, the vendors like to tell you that, okay, they hook up there, waiting patiently for some self-learning cloud or wonderful algorithms to tell the device to do something clever. But in reality, what do the devices do? They suck all your personal data, send it out to some weird internet server that is completely out of your reach and control, and yeah, you're more or less hooked up to the manufacturer of that device, and you're out of control of your own stuff. So talking about the smart home, usually you're talking about your local environment and so your local network. You have your local area network at home. So wouldn't it be a much nicer way if all your devices would also directly talk locally, keep their data locally, and have the logic for interaction working locally? So that's why I actually like to try to talk about the smart home in the part of the Internet of Things as an intranet of things. That should usually be enough to really provide you many good use cases. And another huge benefit of an intranet of things is that you're not dependent on the cloud being available. If you think of your house, and just because your DSL line is down for a day because some digger hacked it and it doesn't work for the moment, if you're not able to operate your lights and your shutters and anything anymore completely, that's simply a no-go, right? So the Eclipse SmartHome project is actually a software framework that allows to build such solutions, smart home solutions, which have this local scope. And I'm not saying that cloud services are a bad thing, but there should be really a cloud service by a trusted party where you say, well, okay, that's okay to send my data there, to do some kind of processing, and to allow me, of course, remote access through that way. But usually you should be able to pick really somebody you trust, and not every single device, wherever it comes from, should send out all its data there. Now, Eclipse SmartHome is a project based on Java and OSGI for modularity. And it's primarily really a set of OSGI bundles to pick and choose from to build a solution for such a smart home gateway on top of that. The two projects or products that I mentioned, openHAB is a freely available open source solution based on this Eclipse SmartHome framework. KiwiCon is the commercial solution we offer from Deutsche Telekom, which is packaged with hardware, so you can directly buy such a hardware gateway in a shop with devices and so on, so everything pre-packaged and pre-configured. And there are other companies working on solutions based on the software stack. Now, when I talk about a set of bundles with functionality, what exactly is in there? Well, Eclipse SmartHome, first of all, describes a kind of simple domain model for stuff inside your home. And for this domain model, it defines events. So eventing is really one of the core concepts. It's all asynchronous, really just having events or asking devices to do something that we call commands, and having status updates and information like temperature values, whatever, coming from the devices in the other direction. Based on that domain model and events, there are mainly four part of functional sections then. First is all about connectivity. So the main idea is that this domain model and event is really an abstracted layer, and you have now specific connectors to all the different kinds of systems, devices, hardware, and so on. So these are called bindings in Eclipse SmartHome and allow you to really modular extend your system whenever you get a new kind of system protocol or device that you want to hook up into it. It also provides a REST API to provide access to all your things in a generified way, and also does discovery on your local network to directly find things for you. Second big block is about automation, because as I said, the smartness should be really automation logic, that things happen by themselves. And here it's about, well, triggering conditions, something that says, well, now some logic should be actually started, actions which are then pieces of code that do something, that might send out emails and so on as well. And having such rules really able to have them modular packaged and easily usable. Third part is all about user interfaces. As I said in the beginning, you don't want to end up with 20, 30 different apps with different design styles and so on, and not finding out how to do more or less the same functionality on a device from a different vendor. So the approach of Eclipse SmartHome is to provide here also a modular way to describe your user interface. You can, as a user, actually declare what kind of content you want to have on there with what kind of widgets. And this structure information is passed through the REST API to the user interfaces then, and there are many different ones. So there are UIs then as native applications for Android, for iOS, HTML5 versions, and so on. So all of them can share more or less the same information that you only define once. Last but not least, it's about persisting the data, as the events per se are not persisted by themselves. So you can set up your system in a way that with a certain granularity or based on certain events, stuff is written to databases, log files, sent to some cloud servers that do further processing with that. So one of the core concepts that you should have heard of is that of an item, which is really the abstraction of a functionality in a broader sense. So it's not directly tied up to a certain device, but you're rather saying, well, it's the room temperature of my living room. How you determine that, which device that is in the end, doesn't really matter. But this is really the piece of information that you're working with inside rules, inside UIs, and so on. And so you usually have multiple items per physical device in the end, because you could think of modeling a radio, for example. So you would say, well, it is actually something where you can switch it on and off, or you would have a functionality to control the volume and another functionality to select the playing station, for example. Now, this separation between the logical modeled world of items and the physical world is really done through these event bus. And as I said, the items are using these events, and based on that you can define your user interfaces, you can define your automation rules, and all of that is completely independent of any physical device so far. So you can really define your UIs, your logic, without having real access to devices. Then the physical connection is done through the bindings, as I mentioned, and they really do more or less than a translation that you can configure of these abstracted events for a specific device. And this is easily then replaceable. So using the same item, like the temperature of the living room, as I said, you can say now, well, okay, so far I've used that device, now I'm using a different one. Maybe the outside temperature is a better example. You could say you start off with a Yahoo weather service to determine what's the outside temperature, then one day you buy a weather station which you can hook up, and you really just have to say, well, now the data comes from a different source. But you don't have to change anything about your UIs and automation rules. Now this is just a list of a few of the bindings that were developed for openHAB from the community. We actually stopped updating that slide a while ago. By now it's 2 or 3 times as many. And you will find there almost every system that is somehow relevant in the smart home context. Now, talking about the bindings in openHAB from the past, openHAB was really a solution for tech-savvy people, for developers like us. And so all the configuration and setup has to be done through textual configuration files. And this is just an example for the KNX system, to wire your data points and so on to an item. That's just the abstract form, what you have to provide there. Just as an example that, well, for a user, for example, for a product of Deutsche Telekom, that wouldn't be a way that you want to offer them, right? So textual configuration is nice for tech-savvy people, but for really reaching mass market, where we have to move away from that and provide more graphical user interfaces, automatic discovery, and these kind of things. And these are really areas where we as Deutsche Telekom currently work on, and which is a major part of the contributions to the Eclipse SmartHome project. And as one of the first results of that, we have these new binding APIs defined, where you have these things available. You can describe your device in an abstract way, and to provide meta information that says how you can actually configure it so that user interfaces can pick up that information. and use it. Now, one of the concepts introduced for these bindings is that of a thing then as a configuration of a unit to be configured in order to use it in your system. So for this, it's really a representation of the devices for the setup purposes. And we're talking about things and not devices specifically, because we're also seeing here, for example, web services like the Yahoo Weather Service or other things I mentioned that could be done through the same way. So a thing in general has just a number of channels, which are the functionalities that can then be mapped to items in the end. A bit more complex, you can also have things that require a bridge device or some other device that you need to configure, set up, make available in your system in order to access them. So any kind of IP gateway in between or so could be such a device where you first have to authenticate against in order to access any attached devices. And for things that have recurring functionality, like an actuator with 5 channels, for example, or channels is not the channel that I mean here, but 5 switches built inside, then you have them over and over again, and you can group actually the functionalities into channel groups here. Now, enough of the talking and the abstract stuff. We're here at an IoT conference, and the good stuff is that everybody brings some real hardware and not just slideware. So I have, first of all, here my Eclipse IDE, where I have openHAB 2, which is the new version of openHAB, which is based on Eclipse SmartHome and brings these new concepts installed here, so I can start that right within the IDE. And as hardware, you will see if we go to the UI, I actually brought mainly, first of all, here two lights with me. The one is from Philips, the Philips Hue system, which is based on Zigbee communication. And this is actually one example where you can't directly control the light, but you first have to go through an IP gateway, which is this thing. So this is hooked up to my router as an IP address. I first have to authenticate against this one, and on here I can then get the configured lights and get hold of them in order to control them. Another bulb that I brought is here a LiveX, which is an Australian Kickstarter project, and it's an LED light bulb that directly hooks up to your Wi-Fi. So this is already now connected to my router here, to the network, and you don't need any kind of IP interface in between, because it has its own IP address and speaks some weird and funny UDP protocol, very proprietary. So if we now go here in our user interface, we see that on the discovery, the LiveX bulb has already been found. Oh, what is not good is that I'm not hooked up to the Wi-Fi. Okay. Let me just, to be sure, restart the runtime, that it knows our own IP address. Okay, should be there. Okay, and now we see it has found both the LiveX bulb and the Philips Hue bridge as a very first thing. We can now simply say, okay, we would like to use that, give it a default name, that's fine. And oh, it now just accepted the LiveX one. Did it? Okay, we're adding that as thing. Okay, now what happens is we see automatically some further devices discovered because we accepted the bridge. Now it queried the bridge, what kind of lights are available. And there are 2 configured the light strips and a bloom. This one is the bloom, so I say let's use that. We can add that to a group. And now here on the list of our things, we don't see the live X yet. Where's the live X gone? There it is. Okay, add the live X. Now everything should be there. So we have the bridge, we have the bloom, we have the live X, and if we go to our control UI, we see here, okay, we can control the one and the other, and this already shows where we have two very different products from different vendors, but we have the same user interface to control them both. Now, this is not too helpful, but this is more or less what you are sold, right? You get some device, you have a smartphone, and you can take control of that. It's nothing really smart so far, especially not as you don't want to take your smartphone just to turn on the light on or off in a room, right? So what is pretty neat is another hardware that I brought. It's a real physical light switch that you can use as a replacement for your existing light switches. And this thing uses a technology called an Ocean, which is a radio protocol on 868 megahertz as well. And the cool thing is you don't need any power cables, you don't need any batteries built inside here. But if I press that,